Assalamu alaikum. Hello, dear students. How is going? In our session today, we have an interesting subject to discuss, which is about the history of discovering the structure of the atom or the model of the atom all over years. So we have some trail of scientists all over years from the ancient years were competites with each other to give each one try to give its concepts about the structure of the atom in the atomic model. Let's take the first one, which was Democritus. Since 400 BCs, which was a Greek philosopher. He not a scientist as we mean. He was a philosopher, which make a meditation, not a scientific experiments, but he supposed that all matter can be divided into smaller and smaller pieces. He called the last piece that cannot be divided as an atom. So he was the first one who called the atom by this name, atom, which mean in Latin, non-divisible. So Democritus had a correct and suitable contributions in this field. So he was correct. And also, Democritus' atomic theory includes some assumptions like the atom are different sizes, atoms are in constant motions, atoms are separated by empty spaces. So Democrats were appreciated, so he was correct. But on the other side, Aristotle, which rejected the idea of the atom of the Democrats, he was some faults, some mistakes, which was very terrible and cause a big retardations in the developments of the scientific researches, because he stated that all matter in our universe surrounding us, in our universe, are made up of four substances only, which was dust, water, fire, and air. And that was a big mistake, because people in this age try to changing each cheap material into expensive one. They even try to change the dust into gold because they are thought like him. They are confident his assumptions and his supposition. So he caused a big retardation in the scientific research. Let's take another one, which was John Dalton, 1807. John Dalton, he detected with Democrats concepts of the atomic theory, and he supply his assumptions about the atomic theory, because he stated that matter is made up of tiny indivisible particles called atom. He stated that all atoms of an element are identical. If the elements are would identical, so the atom will be symmetric. That's very logic. And also he stated that atoms of different elements are different, and that's also logic. Atoms are rearranged to form a new substance in chemical reactions. He supposed that the atoms in our universe are interacted with each other and make reaction to form a new substance and compounds which we use in our daily life. But they are never created or destroyed. So Dalton was correct and has a suitable assumptions about the structure of the atom. Let's transfer to J.J. Thompson's in 1897, which was the higher or the first considerable trial for discovering the structure of the atom, because it was experimentally supported. He made a common and a known experiments to prove that the atom contained a negative charged particles. He called it electrons. So he was the first scientist which discovered the electrons and take the structural model of the atom, including the electron. His structural model had a common name, had a nickname which known as plum pudding or a muffin model. Plum pudding or a muffin model. The negative electron embedded in a positive atom. He supposed that the atom has a circular structure. circular structures which was a positively charged and a negative electron embedded inside it. So it's look like a muffin kindly. So it was wrong in this part. He wasn't take the right field or the right pattern in this point. So let's talk Rutherford trial. In 1909, he discovered the nucleus in a very common and big known experiments, which was scattering Rutherfords. So let's see the description how Rutherford showed that the nucleus had a relatively small diameter compared with that of the atom. Most of the mass of the atom is concentrated in the nucleus. In the beginning, in the early days of the atomic theory, many physicists tried to explain the model of an atom. In 1909, Ernest Rutherford showed that the alpha particles emitted from the decays of unstable radioactive materials were electrically charged helium nuclei traveling at a high speed. So let's take the parts of the Rutherford experiments. Rutherford alpha scattering apparatus. This is the shape and the figure of his experiments. He used a box of a material which absorb radioactive radiations because he put inside it a radioactive material which was a source of alpha particles radioactive rays. He used a radioactive material emitting alpha particles. In order to the alpha particles shooting a foil, a thin gold foil to try at the trial to know its structure. And he used on the other side a zinc sulfide detector. He used the zinc sulfide detector. He used zinc sulfide specifically because the zinc is absorbed radioactive material from the alpha particles. So it's very safe for this experiment. Then this is the idea of the alpha scattering experiments. He used a vacuum medium, and a source of alpha particles and a gold foil, which was the symbol of an atom. He wanted to know the structure of the atom of the gold foil. Then he make the idea of the shadow. He followed the idea of the shadow. He tried to make the alpha particles shoot the gold foil, and if it passes to another side, it will form a fluorescence or a shadow or a mark on other screen. So that means that there are a vacuum or space in the atomic structure, but it is not passed out to another side. That means that the atom was plugged, having space, not vacuum. So that his was assumptions or imagination. Procedures, or the steps, Rutherford fired the alpha particles through a piece of gold foil. He started to shoot the alpha particles from its source at the gold foil and used the zinc sulfide detectors to detect the scattered alpha particles and their location. He observed the following. These alpha particles which is shooted from its source, and those are the nucleus, which he will later observe that. He wasn't observed it yet. He will observe that or discover that after ending the experiments. Therefore, alpha particles will shoot the positive particles directed to the positive particles of the nucleus as it is until we reach to this point, to this stage. The alpha particles have three patterns or have three directions. The first one, it will shock the positive particles in nucleus, and then it will reflect it back, and most of them actually will pass to another side, to the zinc sulfide detector, will pass through the vacuum of the atom, and a small amount of them will repulse it, will diverge it by the positive particles, because the alpha particles was positively charged and the nucleus also positively charged, so it will diverge it, and like that. As we can observe, some of them will pass, most of them actually will pass, and some of them will shock and rebounding or reflected back by the nucleus, and the other will diverge it only. So he can conclude three assumptions or three concepts from this experiment. He concluded that most of the alpha particles passes through the gold foil and undeviated, so that means that most of the atom was space and vacuum. Most of the atom was space and vacuum in order to allow the positive alpha particles to pass. A few alpha particles were deflected from their path but continued through the gold foil. A few of them were deflected and or diverged or repulsed, so that means that the centered mass in the atoms was positively charged, so that it repulsed with the positive alpha particles. A small number of alpha particles rebounded. That means that are a small mass in the center of the atomic structure which rebounded it and don't allow them to pass. Conclusion: from the results of this experiment, Rutherford explained that most alpha particles passed through the gold foil atoms undeviated. Rutherford concluded from that most of the atom was actually empty space, because most of them are passed to the another side. The deviation of some alpha particles from their original paths were due to the positive charge within the foil. This deviation or repulsion was because the similarity between the alpha particles and the nucleus in the charge. Both of them were positively charged. And he assumed that when a small number of alpha particles had rebounded because they collided with something much larger or collided or shocked with a dense mass in the center of the atom, which known after that by nucleus behavior, and which contains a concentrated region of the positive charge. The whole conclusions as a result of his observation, Rutherford suggested the atom had a positively charged center. He supposed that there are a central mass in the atom, which was positively charged because the alpha particles repulsed with it. And he called the heavy positively charged centers as a nucleus. He went on to suggest that the nucleus was surrounded by obtaining electron required for electrical neutron. Thompson before that proved experimentally that the atom contained negatively electron particles. So we know now that the atom have a positively charged particles and a negatively charged particles, and we can observe that all atoms in stable states in the universe have not electrical activity, so it was electrically neutral. That means that the number of negative electrons equal the number of positive protons inside the nucleus.